So, hello everyone. Welcome to the Cloud Robotics Working Group meeting today. Last time we were looking at the Roscon talks, and we came across a very interesting one by. I'm sorry, I don't know how to pronounce your name. Is it Guillaume?
Yeah, Guillaume. Yeah, it's perfect.
Oh, that was pretty close. By Guillaume here from Canonical, who was kind enough to agree to come and talk more in depth about the Canonical Observability Stack. So, without further ado, I'll hand it over. We're excited to hear what you can tell us about.
Yeah, so share presentation. Yeah, that's it. So hello everyone. First, thank you for inviting me to present today. So my name is Guillaume, robotics engineer at Canonical, and since you've already got an introduction to cost for devices, today we'll explore the underlying technologies of cost in greater detail. Some of the slides here are very similar to the one of the Roscon presentation, but this is just to make sure that you've got all the context. So let's start. So first, why do we care at Canonical about observability? Because with observability, we get metrics, we get logs, we get alerts, essentially anything we need to get the operational health of our deployments. At Canonical, we've been deploying Ubuntu as well as large enterprise deployments for years now, and we've developed the infrastructure and the orchestration knowledge that is necessary to run such deployments at scale. And with this experience, we bring a seamless observability solution for organizations that are deploying robots, but also a reliable infrastructure for developers building observability tools. So this solution is a platform that consists of the infrastructure to support the deployment of observability tools for robotics. So the solution is called Canonical Observability Stack, also named COS. We already have enterprises using COS to monitor the health and performance of their servers. But today I'll present to you how you can use it for robotics and also the technologies that are supporting COS. Just a quick reminder, so COS orchestrate open source tools to collect and process data from your workloads with automated configurations and seamless deployments. So it integrates some of the most popular open source tools in the industry, such as Grafana, Prometheus, Loki, Alert Manager. And additionally, we've integrated some robotic-specific applications, such as the ROS2Bag file server to store your ROS2 bags, the COS registration server to bookkeep the registered devices and their configuration. It's the proxy that collects configuration for each device and distribute them to the different server-side application, and Foxhole Studio to visualize robotics data. But also any server application that you could integrate in the future. And this is the server side. On the device side, similarly, we have agent snaps that are sending data to their counterpart server-side applications. Additionally, the device or the robot has a registration agent to automatically enroll the robot in the COS server. This allows you to instantly roll out agents to thousands of your robots. So if you start deploying a COS for devices right now, you get easy and automatic onboarding of new robots in the system, remote monitoring of your robots, ROS2 data and logs access live and in storage. Same for your Linux system data and Linux system logs. With Alert Manager, you get to receive an alert, for example, when the battery of one of your robots is low. And once this observability stack is a crucial part of your deployment, you might want to observe it as well. So you can actually go full inception on your stack and start observing your COS for robot deployments with another COS deployment. Additionally, COS is a platform, meaning it's designed so you can integrate your own application. It allows you to either harness the rich data that is already collected or enrich the system with your own custom applications. So the value of COS resides in the integration of open source software. If we wanted to reproduce a similar setup to COS, but without it, it implies finding all the proper Docker images, properly maintained and so on, learning about Kubernetes, figuring out how to integrate all your apps, configure all your apps. We're talking different configuration files formats, different user interfaces, and sometimes completely different logics as well. And here we haven't even talked about the network, what happened if the IP of one of your applications has changed. So instead, with COS, this is an easy setup, because after deploying, you simply integrate the applications together. Here on the right, you see the page on CharmHub about Prometheus, and you see all the integrations that are available for Prometheus. So on the left, I've added a representation of the integration, and we've integrated Prometheus with Grafana. This way, Grafana can render the metrics in dashboards, and this is done with the Grafana source integration. Similarly, we've integrated Prometheus with Alert Manager. This way, alerts raised by Prometheus can be dispatched, and this is done via the Alert Manager integration. And finally, we've integrated Prometheus with Traffic, our reverse proxy. This is done with the Ingress integration. This way, we can expose Prometheus to the outside world, so our robots can push data directly to the database. So the value, of course, residing in the integration, and how easy one can deploy observability even without being a DevOps. So let's see how to deploy the stack. So with one command line, you can deploy all the server. This you can do if you're deploying in the cloud or on premise. It remains the same. You'll deploy it with the same commands. We rely on Juju, a canonical open source orchestration engine for server applications. And we are using Terraform to provision our Juju deployment with all the server applications that we need, as well as the storage for our ROS2 bags. And once everything's green, we're ready to start deploying the devices. Similarly, for the devices, you need one command to deploy everything, and you can even complement it with your own agents, your own applications on the device. This consists of voice agents that are essentially communicating with their counterpart server-side applications. So I believe you've already seen this video, but I'm going to use it as a support to present you the new features. So recently, we've added new features to the stack, and one of them is HTTPS, so SSL. You can now reach out the server over HTTPS and no longer plain HTTP. And you can do so since we have integrated a self-signed certificate application directly inside the stack on the server. So this self-signed certificate creates a certificate for the server that you can later install on your laptop. And this way, your laptop or your computer or your device, your robots, they can reach out over HTTPS to the server. The HTTPS is happening from a device to the reverse proxy, up until the reverse proxy. Later, everything that is happening inside the server for now is still plain HTTP. But another thing is that with this new SSL and this new certificate hosted on the server, we've also generated a certificate specifically for devices, meaning that now every device has its own certificate. Because in the case of the Foxglove breach, the robots are acting as servers, so they also need their own certificate. This way, you can start communicating over WSS, so WebSocket secured, from a laptop to a device directly and securely. And you simply need one certificate because they are all generated from the server. Additionally, we previously had this very basic file server for the robots, for the bags, sorry. This is a simple caddy server, and we've recently integrated safe storage. Safe storage is much more reliable with many more features for storage. And one example is that we now have an S3 endpoint to store and retrieve your bags. So that's it for the new features we have. So now that you've seen the COS stack in action, let's take a look under the hood. So let's get a bit more into the detail of the backend. So Juju was created as a way to simplify the deployment and operation of server applications and their supporting services. It lets you orchestrate complex deployment made of charms. So now in Juju, a charm is an operator that wraps an application and that contains all the instructions that are necessary for deploying, for configuring, for scaling, and integrating with other charms. In other words, you could say that it's a way to orchestrate the life and the integration of your Dockerized applications. As an example, our Prometheus charms provide all the information, so URL, credentials, to the Grafana charm. This results in our charm or Grafana charms having access to the data without us having to configure anything in Grafana. Because otherwise, you must log into Grafana, find the proper URL for your database, generate the credentials on your Prometheus, store them in the Grafana, and renew them if necessary. But in the case of Charm, we just need to connect them together. So here you can see the output of the Juju status command. This is typically what you would get after deploying with Terraform, like we saw earlier. With the Juju status command, you can get this overview of what's happening on your Juju deployment. So let me break this down. On the top layer, you can see the list of applications that are deployed along with their status. So here, everything is active. This is typically, so the applications that typically correspond to the charms you've deployed. Here we can see on the top, we've got Alert Manager, Black Box Explorer, Catalog, and so on. In the middle, we have the units. So here we have a simple deployment consisting of 1 unit per app, but you could see here multiple if you decided to scale the number of units to handle more requests. And finally, at the bottom, at the very bottom in the integration provider, you have the integrations. So here you can see how applications are integrated together. We see what kind of information or services they provide to one another. As an example, the first one that we see is called Alert Manager and is integrated with Loki. This way, Loki, that stores our logs, knows exactly how to send an alert to Alert Manager. So this is a busy slide, but I want to insist that the main point here is that the robots are configuring their own costs. The central aspect of costs is the flexible configuration distribution. So the agents on the device provide their server-side configuration to the cost registration server. Later, this server manages and distributes application configurations to the other server applications. This server can handle, obviously, configurations that are unique to a specific robot, but also configurations that can be reused across an entire fleet. This simplifies the deployment process a lot because once the server is set up, you only need to focus on deploying your individual robots. So let's talk about how CAS is a platform. So it's a platform for observability. Obviously, you can contribute to it, but you can also extend it and connect new applications to the stack. So let me show you how you can leverage CAS as a platform. So the first point is that all the software of CAS is open source. The value that we add here is how everything is configured and integrated together. You can integrate, obviously, your company solution with the most popular open source apps, and you can even take advantage from all the data since everything is in an open format. You can also benefit from the existing catalog of application available on charmmob.io. And you can even distribute your own application on the Charmmob for wider adoption, whether it's a closed source or an open source application. So recently, Botmine is a great example of the platform extensibility. They benefit from it by easily integrating their fleet management solution with our open source observability stack. This integration allows Botmine to enrich the system with their own custom applications, demonstrating the platform's modularity. Another very good example is Redux Store. Redux Store used our tooling to directly integrate their work to our solution. Redux Store is a high-performance storage and streaming solution, and they connected their performance database to the stack directly. This really demonstrates the power of the open source approach, where anyone can work on and contribute to this stack. So CAS is not tied to any specific technology. It's really open to anything. And as an example, we've recently explored the integration of Zeno with the stack. Here we're using the Zeno router that's hosted on the server directly to forward ROS traffic from a robot to a laptop across the internet. This is possible because the agents and the server apps are modular, so you can easily swap an application for another one if you want to use a specific technology. So from the Docker containers of your applications, you can easily wrap it in a charm and add it to the server side. You can bootstrap your charms with some predefined profiles, like for Django, for Flask, for Go applications. The charmcraft init command generates a whole charmcraft project. Here, we can see that we're calling charmcraft init with the Django profile and the name of our applications. It generates all the files that are necessary to create the charm. But here, the important file that we want to look at is this charmcraft.yaml, the first file. So this charmcraft.yaml is the file in your project that contains the keys declaring information about the project. It can declare the resources, it can declare the integrations, it can declare configurations, metadata, and so on. This is the file that is later used by Charmcraft. So Charmcraft is the tool that we'll use to build charms. And here, in addition to the generated file, we've added an integration called PostgreSQL. So here what we do is that we say that this charm will require a PostgreSQL interface. And this way, our Django app can directly integrate with the database. So now that we have our fresh charmcraft.yaml, we can build the charm with our charmcraft tool. So we run the charmcraft pack command, and this will take our charmcraft YAML as well as the rest of the files and generate this charm file. We can then deploy it, specifying our Docker image. So in our case, juju deploy, then the name of the charm. In this case, it's a local file, but it could be the name of a charm uploaded on charm.io, and then the resources. Here it's a Docker image that you could have uploaded. And now our charm is orchestrating the Docker container. We can now deploy database and immediately integrate it with our application. So here, that's what we do. Juju deploy PostgreSQL case. This is the database already available on Charm Hub. And then we simply integrate our application with the database. And that's it. Here again, we have the Juju status, and the app is now deployed and integrated with the database. So here we've integrated our application with the database, but we could have integrated with anything else. We could have integrated it with a reverse proxy. We could have integrated it with tracing. It could have even been with Prometheus if our application was generating some metrics. This is really the added value from Juju and Charms. Additionally, by using the PostgreSQL charm, we benefit from all the features that have already been integrated into the PostgreSQL charm. The PostgreSQL charm is already exporting metrics, so you can connect it to Prometheus to start having metrics and monitor with the dashboard the various metrics of your database. You can run actions to create backups or restore backups of your database. So just by reusing different charms, you can benefit from a lot of features that you might already need or need in the future. So this is a great added value from using charms. So regarding the future work on the project, the important items are start looking into ROS2 traces in an open telemetry format, write a ROS2 diagnostics message to Prometheus Bridge. This way we could visualize the standardized ROS2 diagnostic messages in Grafana, and we could even create alerts around it, start receiving emails depending on some status. And alerts and dashboard, they're great usage of our data for observability, but we could reuse all this data for machine learning and AI training. So by connecting the different databases to Kubeflow, Kubeflow is a platform to simplify the deployment and management of machine learning. We could reuse all that for all our data for machine learning. So as I mentioned, COS is entirely an open source project, meaning that community contributions are essentials. Here, the community contributions, they can be anything like new documentations or improvements, but since it's an open source project, you can also just try it. You can try it and provide feedback or create tickets about the project from your usage, etc. Additionally, a contribution can be an integration of a new application, whether they are open source or even company products that could benefit from the ecosystem. a new application could do anything. It could consume the data or even contribute to the data that's already present. And yeah, we are very open to help companies integrating their observability tools with our solution if they want to benefit from all the open source tools. Thank you for your attention. We can use the rest of the time to discuss the topic, and if you want later, I can show you a recording of the server-side deployment and kind of show you how it's happening in real life to work with Juju and Charms.
Brilliant, thank you. I'll open the floor up to questions if anyone's got one ready.
I have one. I have a lot of questions, as you can imagine, but I have one quick one that ties up to the end. Commercial charms, how does that look? I didn't see anything about like billing or commercialization or even securing the code and stuff like that. Have you? Maybe this is too early, but have you already engaged in anything like that? Do the contributors have a chance to monetize their charms here?
So there's no mechanism in the Charm Hub to monetize your applications. But as an example, what Redux Store is doing is that the Charm is simply orchestrating their Docker containers that they were already using for their customers, and it's inside the Docker containers that they manage their subscription and their the client accounts and so on. But it's open to a commercial product, but it's not managing any subscription or any payment mechanisms. So.
Thanks.
I'll jump in with a slightly open one, which is have you used it much with robots, and what challenges have you had doing that? Like, have you had intermittent connections from robots, and how has that affected use of the stack?
So the first thing is that for robots, you must assume different architectures. So we immediately had to build all the agents for ARM because most of the robots we worked with were running ARM. Another thing was networking. So you can assume that the IP of the server is public and that your robots can reach it. Obviously, you could have everything on-premise and not connected to the internet, but potentially, ideally, you would like to have your server in the cloud, at least accessible from the internet. But when you need the direct connection from a laptop to a robot, which is the case for the Foxglove bridge, we face limitations. So that's why also we explored a bit of Xeno. And another way of solving this is that we use the peer-to-peer VPN. In our case, we used Netbird. It's an open source peer-to-peer VPN that you can even self-host if you want to. But I guess it's very similar to Tailscale that you probably have heard of. Yeah, that's why we would like to eventually move to a way of not having to let the user figure out the network solution. But for now, yeah, this is a constraint. But I guess it's true for every setup currently.
I was expecting the robotic question to come straight from Christian. Instead, he's taking it. He went first to the commercial. I also wanted to ask about robots because we spoke a lot about observability, about robotics, and we saw somehow that robots generate a lot of data, most of the time so much data that you actually don't stream it over the internet to look at the fine details. So have you had any experience with this? How do you deal with, and connected to this question, you mentioned that you have configurations on the client, so on the robots. Is that configuration something that you could change dynamically, for instance, to increase the rate at which some messages are published or this sort of things? Thank you.
Yeah, so currently we have the configurations that are distributed as a bunch of YAMLs inside a Snap package. So you could redistribute a new configuration and deploy it over all your robots. But you could also modify the file directly on the robot, or this configuration. So currently we had two agents that needed this kind of finer configuration for topics. The first one being the Foxglove bridge. You might not want to expose everything. That's why also we tried with these Zeno, so Zeno to DDS bridge that only streams the topic that you actually subscribe to. So it's great because then you don't need to you can expose a lot of things and only consume what you eat essentially. And the second one is this ROS to bag exporter. So we are offering to constantly record ROS to bags and sync them on the server. Similarly, there you can specify the amount of the topics that you want, and you can even specify the size of the bag, the maximum size of the bag or duration that you want. This way you can just, let's say after 2 minutes or 200 megabytes of data, stop the recording, upload the file, and start a new recording in parallel. But yeah, that's really up to the usage of everyone and how much storage and bandwidth you can afford.
Thank you.
I'm just writing down. I think there was a lot of information in there. So I guess the upshot of that is that you have also found that you can record too much data on a robot and found the need to scale down.
Yeah, and we've also integrated a mechanism that would eventually clean the old bags on a robot if you can't sync on the internet to avoid bloating your disk. But yeah, that's really the fine-tuning that people would have to do depending on their robot, depending on the usage. I guess in an early stage of deployment, you would rather upload a lot of data, and the more you're confident with your robot, you would maybe reduce the frequency or the amount of topic you want. I guess if you have thousands and thousands of robots, you might not want to record 30 FPS of your laser scans for all your robots.
Speaking about thousands and thousands of robots, how many robots do you currently have running this in production?
So currently we have about one usage with about 1,000 devices running, but since it's an open source project, we might have people running it, without us knowing. We've tried also internally.
Is that 1,000 robots, or is that 1,000? Is that for COS, like the original application of COS?
No, it's for devices. Let's go. Yeah, they're not maybe not robot per se, but devices. Yeah.
Yeah. Okay.
That generates data.
The reason why I'm asking is, of course, because we have a particular interest in robots, and we think that robots behave differently than a lot of other devices, for a lot of the reasons that you've already touched on. Can you say a little bit about the history of this? Like when did you at Canonical start working on COS for robotics? Why did you choose to do that? Like what alternatives that are already existing open source did you consider, and what were the reasons why you dismissed them, or felt like you should start something from scratch?
Yeah, so I can give you a bit of context. So originally, we only had this COS stack, which was really meant to observe different servers and our deployment. The reason is that at Canonical, we have to run deployments for some customers, and it became a requirement that any deployment that we do for customers have to be observable. So they have to export metrics. We have to be able to monitor them to see if everything is up and running. So this observability initiative started to spread in the company for every product. When we want to deploy something internally at Canonical, it has to be observable, which is why COS for devices, COS for robots, has to be observable. Like this is a requirement. That's why you can observe it with another COS deployment. So the robotics team saw the opportunity for robotics to reuse such a stack, especially because robotics companies would rather focus on developing the robot rather than developing and maintaining a new infrastructure like everyone would essentially reproduce the same. And there was no big open source observability solution for devices out there.
So that's what I want to double click on. So we've been developing Transitive for 5 years, and of course, not everybody knows about it, but that's why I was asking about the history. I'm kind of curious when you decided this, because the way that I see it, and I don't know whether you even know about Transitive, but it's an open source framework that has a lot of the things here that you describe here, but it already solved a lot of the problems that you haven't solved yet, but that you've already run into. And I don't want to steal the conversation, so I'm not going to go too deep into it. But my question is, and I'm not phrasing this well, but why aren't we working together? Why did you guys decide to build a new one? And maybe it's just a matter of you guys not having heard about it, but that's the question that I want to get to, right? Like there's the way that I see COS is, as you pointed out, it's mostly an orchestration of existing tools. So in my mind, the way I'm separating that is there's the actual infrastructure that you provide, right? And a lot of it is charms and Juju, and you're sort of adopting that. And then there's the content, which is, Foxglove Bridge, Grafana, and so forth. In Transitive, we have a very similar sort of separation. We call them capabilities, which are the, in your case, the charms, except that we also build a lot of the capabilities themselves. It's not just wrappers. But then the infrastructure side is a lot more elaborate and sophisticated, and it's based on a long history and experience in deploying hundreds of robots. And some of the pitfalls that you walked right into are things that we solved from first principles. In particular, I'll just use this one example, which is the networking. Robots should never be servers, right? It's just wrong. And you saw why, right? You cannot have all of your operators be on the same VPN with the robot just because they want to use Foxglove Bridge to teleoperate them, right? That's the wrong design principle. So anyways, there's a lot of these design choices that need to be made. And so I just was curious how you came about to this one. But I guess you answered it. You felt like there was COS was already there for servers. This is actually really funny, right? Because most robotics companies fall into exactly that trap. They think that robots are servers, they're like backend devices, they're not a browser. So let's treat them like a server. What good tools exist for server monitoring? Oh yeah, I know, Grafana, Prometheus, Loki, whatever, Ansible for configuration management and so forth. And then they apply that to robots, and then they realize, shit, that doesn't work. And it has a lot to do with the network and the fact that robots are often offline. So I think you're tracing the same footsteps that a lot of robotics companies have gone through, and you are now coming around to realizing that you should probably architect it a little differently. And maybe this would be a good time for us to chat about, collaborating offline.
Yeah. So first, I don't think I knew about transitive robotics before that, but one thing I can mention is that we really focus on the infrastructure, as you said, and not so specifically about the applications. So we've integrated certain applications because they were rather famous in the robotics world to collect data, to visualize some data, and so on. The Foxglove Bridge, it's we anyway faced the situation where when we started to work on this course for robots, Foxglove was still open source at the time, and it went closed source in the meantime. So we faced the situation where the Foxglove Bridge is still open source for sure, but Foxglove Studio, we still have the old open source version running. So anyway, we don't focus on one specific tools. We will be open to have any other tool, and that's that's why I mentioned about the Xeno work we did as well. So yeah, having the robots running the Foxglove Bridge is not ideal, but we couldn't find for now a better way to have live access to all the data of your robots. And except for the Foxglove Bridge, we have this really pushing model where the Grafana agent is pushing like logs and data to the server. So the robot surely needs at some point an internet access or an access to the server if the server is hosted in a warehouse, let's say. But yeah, this Same for the bags. It's just for the Foxglove bridge that we have this limitation, which is why we're also looking for alternative. And since Foxglove went closed source, anyway, we'll be open to essentially adding any tool on the server side or on the device side to improve that. But yeah, that's a specific choice to have this Foxglove bridge server running on the device. Yeah.
So I suppose that nearly everything you have running is pushing data, like you said. So it is acting as a client, except for the Foxglove bridge, and that's because you used an existing app or an existing server. So instead of turning it into a client that pushed, you wrapped it in your ecosystem, and that was your focus.
Yeah. So it would be redeveloping an entirely new system to have the Foxglove bridge acting as a client in this case rather than acting as a server. So yeah, there's no like we couldn't really have done it the other way around. In the case of the Zeno example that I showed, I actually kept using this Foxglove bridge. So on the right, you have ROS to DDS messaging. You've got this Zeno DDS bridge. Zeno DDS bridge is connected, pointing to the Zeno router in the server. So this IP has to be reachable. This Zeno router, then I have the Zeno bridge DDS, so converting Zeno back to DDS, and then the Foxglove bridge. This way, you can have your laptop communicating to the Foxglove bridge hosted on the server. But like this is just an example. In the future, we could hopefully have a tool that can maybe read ROS directly, because connecting to the Zeno router, like in such scenario, only the Zeno router needs an IP that is reachable by everyone, so laptops and robots. So yeah, that's
now you can use Zeno directly as a middleware in ROS, so you just connect to the router without using DDS.
Exactly, yeah.
I have a somewhat related question, which is, are you able to SSH into a robot or even remote desktop or any kind of... I know you can remote teleoperate, which I assume is using ROS commands, but can you do a full remote control? And if you didn't have the VPN, would you still be able to? So
if you have a VPN and you can... and you have the port 22 open, yes, you can SSH, but there's no mechanism specific inside the COS to allow you to SSH or shell. At least right now, there's nothing. Into the robot. It's really, the idea is not so much to act. I mean, we've got this teleoperation thanks to the Foxglove bridge and this whole mechanism. We can hope in the future to get rid of this Foxglove bridge and do directly ROS2 or Zeno communication, even over the server directly to the robot. But there's no SSH access to the robot. It's
the big difference, Mike and Giovanni, that I'm noticing here is that this framework doesn't seem to have a communication layer itself. It's just an orchestration engine. And then if you want to communicate, you need to provide that inside the charm, right? So that's very different from transitive, where you have like that communication layer with MQTT is part of the platform, and it's a given, right? And then inside the capabilities of what would correspond to charms here, you can already rely on that. So I think that's an architectural difference that I'm perceiving.
Yeah, and also in transitive, you have the communication layer that is, you know exactly, it has this optimization that you're doing where you're basically not bringing over the data that is redundant, or I don't remember what you call that functionality, but that's really useful for reducing the bandwidth, basically.
Yeah, in this so in this case, we really have one device, as you said, having its own one agent, having its own communication channel to its application. So the Grafana agent, in this case, speaks directly to Prometheus and to Loki. It is configured by one application that spreads the configuration and makes sure it's working fine with the rest of the charms. But yes, you will have the Grafana agent having its own stream of communication, and it's also a way to make everything modular and to make essentially you could add any application. You could add it tomorrow to the stack just by charming your the server side or installing your agent on the robot. Yeah, that's architectural difference. Yeah.
I like the verb there, to charm something is to put it into your framework. That's quite cool.
Charming.
We had a hand up from Mirko.
Yeah, I just wanted to comment. We considered having a communication framework. We decided to leave this to the final user. That was intentional. We could put, like, we even tried like MQTT proxy that would basically aggregate data from the robot and just pipe into the server and then just be transparent to the user, right? So this was an option. We realized different VPNs offer different abilities, and we just didn't want to pick one. That's basically the reason why this seems to lack secure encrypted layer in between, right?
Yeah, so but the real reason to use MQTT or something like that, which is why we chose it in transitive, is because you don't want to have a VPN. Like, you want to be able to work. So we had 100 robots deployed in hotels and hospitals, right? And even establishing a VPN is sometimes not allowed by the network that you're on. Some firewalls will not even allow you to do that. And then what are you going to do? If you rely on a VPN but you cannot establish it, the only thing that you reliably can get in almost any network in the world is an HTTPS connection outbound, right? Not inbound. That was the big reason for us to go with MQTT. And then once you have that connection established, then on top of that, you can obviously go bidirectional, right? Because it's a standing WebSocket. So different design philosophy. I definitely see your reasons, but VPN is a dirty word in robotics once you get to scale. Right?
It sounds like you think we are suggesting a VPN, but what I really said is we are not suggesting a specific communication framework. So if a VPN is not working for your case, feel free to put an MQTT snap in the robot and an MQTT charm in the server. It's going to work, right? I'm not saying just go VPN. I'm saying feel free to welcome any other thing. So
yeah. And I think that's where it's a different philosophy. It's much more about orchestration, as Guillaume pointed out, as opposed to an opinionated framework for building robotics, like full stack applications. On that note, if I may, since it's orchestration, we've had here in this group had Tomoya present about Kubernetes, like what was it?
KubeEdge, yeah.
KubeEdge, thank you. Yeah, like Kubernetes on the robot. How would you compare what you have built? I mean, I have to apologize. I'm not totally up to speed on Juju and Charms, but it looked very much like Kubernetes and pods. Is that a fair analogy, or how would you compare these two? If I'm a robotics team, why would I choose Juju over Kubernetes?
So you would actually choose the two. Juju and Charms are using Kubernetes in the background. It's just that it's simplifying the whole Kubernetes configuration for you. And the difference is that to Tomoya's infrastructure is that Kubernetes is not running on the robots. So robots are just can be plain Ubuntu, just running agents, sending data. The server is running Kubernetes, but you just don't have to manage it yourself. You just manage Juju and Charms, and you just scale your applications, and it takes care of all the Juju configuration for you. That's how it is in the background. Yeah.
On a similar note, something that we thought was great from KubeEdge was that you could apply capabilities to a robot. Maybe capabilities is the wrong word, given we've been talking. Transitive has a different definition of capabilities. But let's say that you had a camera on your robot. You could tag it as having a camera, and it would automatically deploy software for a camera. It seems possible to me that you can have a charm for running a camera. You could deploy ROS2 using a charm. Is that something you've looked into, and can your infrastructure handle conditional deployment depending on the robot's abilities?
Yeah, so as Emiko mentioned, I might clarify the difference between snaps and charms. So the charms are really meant for server applications. So you, in the case of a server, you wouldn't really connect, I guess, a camera to the server, but you could have conditional deployments in your Terraforms. So in case you don't know, Terraform is essentially a list of applications you want to deploy, how you want to integrate them, and so on. So you could potentially have multiple deployments and even install an additional application that in 3 months from now you want to remove. That's fine. You can just make your deployment evolve with different Terraform, just updating your Terraform files. Now, for the robots, they are not running charms because they're not running Kubernetes, they're not running Juju, anything. They're really just running a Snap. So Snap packages are safe-contained software packages. They contain all the dependencies, and they are secured in a way that they can only access what you've declared. So let's say that tomorrow you install face detection Snap. This face detection Snap will embed your PyTorch pipeline, your model, and everything, and we'll have access to the camera interface. This way, this Snap application can interface with the camera. And the great advantage of Snap is that you can easily install them. Since they are self-contained, they will always work how you tested them, and you can easily remove them, change them, even upgrade them from one track to another. If you had let's say a beta version, you can simply upgrade it to stable once you've got or to the new version. And we have even Ubuntu Core, which is an operating system that is dedicated to devices, where Ubuntu Core, you can only install snaps, and you can predefine in advance what's going to be installed on your device. This way, you kind of create a custom Ubuntu Core image that you can later write on the disk, and that will contain all the software that you wanted. And in the future, you could make this set of snaps change over time if you wanted to. They are essentially two different worlds communicating together, because they have different needs.
That makes sense. That makes sense. So the snaps for, let's say, Foxglove Bridge and Grafana Agent are installed by the charm that's run in your deployment?
No, they are first you will install the charms with Juju. So by running Terraform, this way all your deployment will be done in one go, and then you will deploy the snaps on your device. But you can do it manually, or you can automate it. Depending on how you want, via an Ubuntu Core image, or via just install them at first. And this registration agent, it will try to communicate with the server, and if it can reach the server, it will register the device for you. So it will register on the server. This way, the server will have, okay, this robot number 123. It's available at this IP. It has this name. It was created that date, and it has those attributes. So, or this configuration, for example. That's.
See, I think my point of confusion was that the server deploys, but that's not true. You said at the start, the way you deploy a device is you do snap install and a list of snaps. I got confused there. Sorry about that. We do have a question in chat from Phil. Shall I read it, Phil, or would you like to say it? Three seconds of silence, I'll say it. Phil says, I can see challenges for non-experts in using COS or transitive. By non-experts, I mean most robotics engineers and all students. So how do we educate these engineers so that they learn one of the solutions properly, instead of just hacking whatever the LLM spits out at them? That last phrase stung some of those experiences.
So I can't speak about transitive because I haven't tried it. But for COS, really the focus is on simplifying the deployment. ideally, I mean, as a first-time user, so a non-expert user, you wouldn't probably charm your own application and charm the or snap your own agent. You would just probably deploy it and hopefully maybe customize it with some of the applications that are already available on the Charm Hub. So that's why we also invite companies making observability tools to charm their solution, even if they are closed source and paid services. This way, as a user, you would simply to deploy the new application and integrate it. It's kind of the idea of those integration that you don't really need to know all the details about how this integration connects to a database and everything. You just integrate them together. So there's, of course, a bit of a learning curve, but it's less scarier than having to learn a Q&A test for the next 3 weeks.
So do you have, for example, this is from me, this one. Do you have, for example, a good example stack that you would suggest that they can then tweak for themselves?
Yeah, so we have we have a basic deployment that will deploy essentially what you see on screen. It's a great starting point. Of course, it's to customize over time if you want more applications, but it's a great starting point. We have additionally 2 alternatives. Either you want the basic file storage that we had previously in the video, or if you want the safe storage, you can also deploy it. We have a Terraform for all of this. I can drop a link here if anyone's interested.
And we're quickly coming up to time. So if anyone has any questions to ask before the end, while Guillaume looks up the link, please go ahead. Okay, in that case, I think we've asked all our questions, so we'll wrap up there. Oh, if you could, yes, I've copied that link out. I think I'm very tempted to try this myself, if not with the group. So maybe a future session can be a tryout of the POS system. That's how you can say
that'd be nice.
So with that, thank you again for joining us. Really interesting stuff. We were hoping for more technical detail after watching the talk, and that's exactly what we got. So brilliant stuff. We currently don't have a plan for next session of the Cloud Robotics Working Group. We may do a tryout. We'll discuss amongst ourselves and decide what we can focus on. So thank you everyone for joining. I'll let you know when the YouTube link is up, and see you next time.
Thank you very much. See you.